Hi everyone, welcome to this session. The main agenda of this session is to understand what is DevOps and what are the tools that we are going to be covering as part of the DevOps course. So let's understand what is DevOps. So we all know that service delivery or SDLC, software development lifecycle, has two teams. It comprises of two teams. They are the development team and the operations team. So the main responsibilities of the development team comprises of designing the code, creating the code, and building the code. Similarly, the main responsibilities of the operation team involve monitoring the application that is developed by the development team and also fixing and also they will try to figure out these bugs and issues that come across the application that the developers have built. So the work from developers to the operation teams does not work hand in hand. Prior the application is being developed by the developers. Once the developer develops their application, the testers and the operations team will try to test and monitor the application that is developed by the developers. So when developers are working, the testing and the operation team are idle. And when the operation teams and testing team are working on the application that is built by the developers are idle. So this undoubtedly extends the timeline and delays the software lifecycle, right? So to avoid the wall of confusion between the developers and operations team, we have the combination of DevOps, which is the combination of development plus operation. So when you see the image which is on the right corner, it has an infinite loop wherein the dev and operations are together. So the operations and the development team will plan the code in a way that the application is being developed by the developers, the code is being written, the application is being tested and built by the developers, and again, the operations team will deploy, operate, monitor, and plan the application. So this is an infinite loop, and this happens in a continuous manner, which we call it as continuous integration, continuous delivery, and continuous deployment. So once the continuous, we have a lot of tools which are to be integrated with the continuous integration platform, and then it has to be deployed, and then it is delivered. So this is the beauty of DevOps, wherein there are good amount of resources, good amount of tools which are integrated with DevOps, which will make the operations and development team working hand in hand, and there is no space of uh, confusion created here. So now let's understand what are the tools and what happens in the DevOps. So the DevOps team makes SDLC easy as they follow the steps that we have mentioned here. So the developers plan, they code, they build and test the application in the local environment, and the operations team deploy, operate, and monitor the application in the Kubernetes or maybe the OpenShift or Azure Kubernetes or any cloud, Google Kubernetes, any kind of Kubernetes platform. They deploy their application onto the microservices. They monitor the application, and if there is a bug or an issue that has to be fixed, they continuously fix this in cooperation with the development teams. Developers and operations team work hand in hand to make SDLC easy. So now, what we'll understand what are the tools we are going to be used and the purposes of these tools in the DevOps platform. So what is Git? Let's understand Git. Git is a source code management. So, so when I say source code management, the developers when they write their source code, or the DevOps person who uses their YAML files for the manifest files or a Docker file or any code related issues, any code related info is being stored in the Git. So Git stands to be a version control or a source code management tool which has our code. And let's understand what is Jenkins. Jenkins is a continuous integration and continuous delivery platform wherein Jenkins is the heart of DevOps, which is integrated with the rest of the tools mentioned here, like Git, Maven, Nexus, SonarQube, Ansible, Docker, Kubernetes, Terraform, and so on. So anything which has to be run, that will be run as part of Jenkins pipeline. So Jenkins will get integrated with the rest of the DevOps tools, and we will run the Jenkins pipeline, and Jenkins pipeline is responsible for the continuous integration and continuous delivery and deployment. Now, let's understand what is Maven. So Maven is a build tool. Once the developers are done with their coding, we have we have to test the code, we have to compile the code, right? So we have Maven lifecycle, which has Maven test, Maven validate, Maven compile, Maven build, Maven clean deploy. So all this lifecycle, which is related to Maven, it is responsible for compiling the code written by the developers, test the code which is written by the developers, and finally create a package create a package of source code written by the developers. When it is containerized, this package will be executed in the microservices. And let's understand what is Nexus. So Nexus and JFrog are the similar artifactory tools, wherein we have repositories in the Nexus, and the dependencies of Nexus are defined in the form.xml, which is related to the Maven. And again, so whenever we have the packages which are related to Maven, the packages like jar packages and var packages. So if your application is web-based, we have var packages. If your application is Java-based, we have jar packages. All these packages, and also your Docker files, and also your Helm chart, any kind of artifacts which are related to your project can be stored in the Artifactory repository like Nexus and JFrog. Now let's understand what is SonarQube. So when I say SonarQube is a code quality assurance tool. So whenever the developers write their code, it's mandatory that we have to generate a report which gives you a code coverage, which has 80% of the code is being covered as part of your code coverage. Or maybe you also have a Clover report which will generate the code quality. So it states you if your code has any code smells, code bugs, which has to be undergone or which has to be fixed before this is being deployed into the production. All this info is being provided by SonarQube. And if this without solving these code bugs, we could not move ahead into the production. So that's how the SonarQube plays an important role in understanding the bugs and issues which has to be fixed. Now, let's understand what is Ansible. Ansible is a configuration management tool which is typically used in deploying your software applications into the multiple hosts or multiple instances or VMwares where you can install your software into multiple hosts. Now, let me say you have a team of 10 developers, 10 testers, and 10 operators. The stack which is being used by the developers, testers, and operators are different. Now, if you have to deploy the set of softwares used by the developers in a set of VMwares, you could not, it's not a mandatory that you have to log into single instance and deploy the software. So you have an Ansible playbook, and it has an inventory, and inside the dynamic inventory, you will provide a set of the IP addresses of the developers as a group, testers as a group, operators as a group, and you will try to write a playbook, and the playbook has a set of softwares required by the developers, testers, and operators. When you run the playbook, it will make sure that the dependency of the softwares are installed on the mandatory hosts so that the daily day in and day out activities of the developers, testers, and operators are carried out. Now let's understand what is Docker. So Docker is a microservice or microservice for the containerization. So basically, prior DevOps, the application used to be run on the physical servers. And maintaining the physical servers are very hard, and maintaining the physical servers is very costly. And once the microservices is up in the market. Everyone are going for containerizing their application, which has a good amount of very wide range of users about the Docker. So you can have your application containerized. So we'll be explaining you what is required for containerizing your application and how to migrate your application from monolithic architecture to the microservice architecture. Now let's understand Kubernetes. Kubernetes is a container orchestration platform. So basically, Kubernetes is an ocean which has a lot of resources, and Kubernetes can be EKS, AKS, GKS, or OpenShift. And so whenever you have a container, the container requires an orchestration platform wherein you provide a namespace, you provide a service account, you would provide a persistent volume, you will provide a persistent volume claim, and also and so on. There are a lot of resources which are required for your application, which is inside a container to be healthy and running perfectly all right, so that your business is uninterrupted. So achieving zero downtime deployment, achieving an application running healthy and monitoring the application using Prometheus and Grafana is possible with Kubernetes. Now let's understand what is Terraform. Terraform is infrastructure as a code. So whenever you want to set up an infrastructure for your team in the cloud platform, you would not do that manually. You will be having a script which is called HashiCorp language, and this is being integrated with all the cloud platforms like AWS, Azure, Google Cloud, and so on. So you could create your AWS or cloud resources and infra setup automatically using Terraform. Now let me get into the course content that we would be explaining as part of our course. We will be explaining what is Git, how do you create the branches, what are the Git important commands that you use in day in day out activity, and what is the difference between Git pull, Git push, and Git merge, what is Git stash, and how to resolve the merge conflicts that exist any while you are doing your day-to-day activity, and how to manage Git, right, to make sure that you would be a professional in Git. Now let's understand what is Jenkins. So as part of AWS course, we'll be having a AWS free tier account, and we'll be explaining you the installation of Jenkins. So the main reason of our course is to make you understand the installation process as part of SRE, Site Reliability Engineering. Apart from DevOps, you will also learn the installation of all the services, which would be helpful in making your site reliability engineer work also carried out. Now, we'll help you in understanding what is the main Jenkins plugin. We'll explain you the Groovy script, which is required to run the pipeline, and we'll be explaining you the master slave architecture. We'll also explain you how do you integrate your Jenkins with the DevOps tool. And now, as I said, Maven being a build tool, we'll be explaining the Maven installation, Maven lifecycle, and how to set up the dependencies in form.xml to integrate Maven with Nexus, Maven with SonarQube, and so on. So the Maven commands, which are very important for your day-to-day activity, we'll be explaining you as part of that course. And now let us understand Nexus. So we'll be explaining the Nexus installation, the Artifactory repositories to be created as part of Nexus, and how to integrate Nexus with Jenkins, how to set up the dependencies in Maven for deploying the artifact using form.xml. Now let's move on to SonarQube. We'll also explain you how do you create a SonarQube installation, how to generate SonarQube code quality report, which is indeed required for the developers to understand the code fix, code bugs, and code smells. And also we'll explain you how do you write the dependencies in Maven for form.xml to integrate SonarQube. So now, as part of the Docker course, we'll be explaining you the Docker installation, how to write your Docker file, and the components which are used inside your Docker file to make your application executable. And also we'll explain how to how to create a Docker image out of the Docker file, how to manage the Docker images inside the Docker Hub repository, how to create a Docker container, and what are the bind mounts and network policies, what are multi-stage Docker files. Now, Let's move on to the Kubernetes, which is a ocean, as I said. It has good amount of resources. We'll be explaining you the installation of your Kubernetes, which is a control plane, the master node, the worker nodes. We'll be explaining you it with kubeadm, kubectl, and other components. We'll be explaining you the Kubernetes architecture, how to write your manifest files to create the deployment, how to create a horizontal pod autoscaler, how to create an ingress controller, and most importantly, we'll be explaining you what is Helm chart deployment as well as part of our course. So we'll be explaining you the difference between the deployments, daemon set and stateful set, and what are the services that we are going to use like cluster IP, node port, and load balancer, and what are the config maps and secrets, and how do we use the resource quota for nodes and also the pods. And we'll be explaining you the automation process that we are going to do using the Jenkins to deploy the deployment in Kubernetes platform, and also how to monitor your application using Prometheus and Grafana. Now, finally, we'll be moving on to Terraform. We'll be explaining you the Terraform installation. How do you write a HashiCorp language to create your infrastructure? We'll also explain what is state files, what are backends, and how do you write a modules for the VPC, for the load balancer, and all the cloud infra setup, and what are the provisioners that we are going to be used. That's all with the Terraform. And finally, we'll be going ahead with the Ansible, and we'll be understanding how to do an Ansible installation, Ansible architecture, and we'll understand what is a dynamic inventory and how to write your playbooks to configure software in multiple hosts. And it's important to understand what are handlers and how to deploy playbooks using Ansible Tower. So this would be our course content, right? And thank you. Thank you for being there.